Today we were doing radicals. Last lesson we did, 8.3, was adding and subtracting. And then 8.1, 8.2 were over reducing radicals. Now, not a huge surprise. Today's in my opinion, I would say pretty easy, except for the reducing radical part. So just like adding and subtracting, in my opinion, the hard part's reducing radicals. So we kind of have already done this a little bit. When we reduced radicals, we took like the square root of 27 and we split it up into 9 times 3. Well, today we're just doing the opposite. We have the square root of 9 times the square root of 30. We can multiply those together to get the square root of 27. So with this, if you are adding and subtracting, we talked about this the other day, you have to have the same index number and the same radicand. Remember that index number is the number up front here. The radicand is the one in here. They both have to be the same for adding and subtracting. With multiplying and essentially dividing, they do have to have the same index number, but the radicand can be different. Now, I will tell you, I'm not going to pull any facts. I'm not going to give you any where there's 2 different index numbers and try to trick you. I just need to make sure I tell you that because I want you to at least be aware of the rules. Words of wisdom, always check when you're done to see if you can simplify. When you're done, double check your answers, see if you can simplify anything else. Today. So, just to give you an example of what I mean by that, when I say, in my opinion, that's the hardest part of today. Here's how you multiply the answer. This is the new step for today. So, question 1A, I have the square root of 6 and the square root of 18. They're both square roots. So you just multiply 6 times 18. The square root of 108. Now again, we're not finished, but just to show you, number 2, the square root of 5 times the square root of 8. 8 times 5 is 40. Number 5, the third root of 8, so that's the third root of 40. Number 4, we're not really going to talk too much about this, but you multiply those, so on and so forth. All you do is you multiply the numbers inside the radical. Square root of 49. That's the new stuff today. You're just multiplying. However, the part that gets annoying with this is that once you do that, then you can still reduce this radical. So get out your exponent sheet, go through this, make sure. So I'm going to read now, and now I'm going to talk about, I'll actually probably just redo them, but talk about how to actually do these problems and reduce. Now, one thing you'll notice, problems, my computer doesn't, here we go. Problems or some problems is you have 2 options. You can simplify first at the beginning, or you can simplify last. I don't care when you simplify, but I will give you a heads up. And I'll show you in this example. There are times that you'll simplify and then multiply, and then you'll have to simplify again. Now, there are positives to that. We'll talk about it in a second. But I personally would recommend just multiply first. Don't worry about simplifying. 6 times 18, we just said was 1. And now we can reduce that. So go over to your exponent sheet. This, again, I am not saying that this is easy, but we've done this enough that you guys should be either pretty good at it or at least pretty solid. You need to make sure you're asking, and you need to figure that out and get some of that practice. But 108, if you take 108, again, we're trying to find a factor on our list of 108. So you divide 108 by 100 is a decimal. 108 divided by 81 divided by 64. Gives you a decimal. 108 divided by 49 is a decimal. 108 divided by 36 is 3. Gives you a 1. Into 36 times 3. And the reason we do that is because the square root of 36 is 6. If I didn't give you guys enough room, I apologize because I struggled as well. The multiplying, in my opinion, isn't too bad, and then the rest of it's not. I mean, it's not easy by any means, but we've been doing it literally since we started this chapter. The other one is same problem. It's just if some of you guys decide, actually, you notice that 18, it goes over there, that 18 you can simplify because it's a factor of 9 is a factor of that 18. Okay. And that would be great. There we go. So 18 you could reduce into the square root of 2. The square root of 3 root 2. So far, this is fine. You could do it this way. And then when you multiply the 6 and the 2, so you end up getting 3 root 12. The problem is, now you can reduce 4 times 3. Square root of 4 is 2. So you end up with 3 times 2 times the square root of 3, which is 6 root 3. So that's your final. That's what we got before. The benefit to doing it that way is you do not need your number sheet because the numbers are pretty small, like 18. Most of you guys could have gotten that one in 12. But I wouldn't do that. I would do the first way because, again, the problem that a lot of people have with this is reducing radicals. And so doing it twice in one problem gives you twice as much chance to make a mistake on that. Okay. Moving on. So number 3 are exactly the same problem. The only difference is number 3 has a third root with that. Number 2, 5 times 8 is 40. Once you get that 40, though, now you can reduce that radical. So 40, to use your chart, you can try and ends up being 4 and 10. And the reason I picked 4 is because that reduces that to just 2. Now, don't forget, you need to make sure you're showing your work. If you do not show your work, I'm not giving you any credit. And specifically, this is what I'm looking at. Because I know that a lot of this people can do in their calculators. The square root of 40 will just give you that answer. I get that. That's why I need to see your work with this, and that's why on the quiz, I'm actually trying to not do problems like this. I'm trying to do problems like number 3, because they won't do third roots in your calculator. I need to see your work. If you don't show me that step, I'm not going to give you credit for it. Again, I apologize. I don't know harsh, but your calculator doesn't work for you. So the other option is to not let you use calculators on any of it, which sounds equally terrible. Again, it ends up being 40, but now it's not 4 and 10, because those are perfect squares, not perfect cubes. We're looking for a perfect cube. So now instead of using this one, you're using this column. And if you look 40, there's only 2 options, 27 and 8. 27 doesn't work. 40 divided by 27 is a decimal. So this ends up being the third root of 8 times the third root of 5. Now, this is a good example of, honestly, this one would have been a lot easier if you were, because if you notice, I started with 5 and 8, and then my second step was back to 5 and 8. So you could have, if you would have noticed this reduced down to 2 right away, you could have done that. That's fine. But I personally, again, I like to do everything the same way, even if that makes some of them more difficult. I'd rather do that so you don't have to memorize 10 different ways, 12 different things to check before you start, or any of that. Now, this is where I'm going to be a bad teacher. Number 4, I have negative 16 and 4 to get negative 64. And the lesson I'm trying to show you with this is you can't take this, but you could take the third root of the negative. I'm not going to finish that. I decided I'm not actually going to put any of those on tests or quizzes. I guess maybe I'll put them as extra credit. You guys get a lunch. But we're going to skip those negative problems. So for the bell ring, I was just saying that you cannot take the square root of a negative number. That would give you an imaginary number. You can, however, take the third root of a number. Actually, you find out that any odd index you can do, like the 5th root of a negative, the 7th root of a negative, any even number you can't. And I would love to go into that, but I don't have time. Um, sorry, I'm distracted. Quick, just so you get the concept, and we'll talk more about this later. But the square root of 7 times the square root of 7, you can do this the long way, where 7 and 7 is 49, and the square root of 49 is 7. Do it though, the square root of 7 is the square root of 7, that is the square root of 7 squared. And remember, a radical and the exponent then cancel each other. Now I will say, provided that the index number is the same, so that's just 7. My rule of thumb is to cancel out the radical, you need however many the index is. So if the index number is 2, then I need 2 of them to cancel. So for instance, 6 would not cancel because I need 3 of them. Whereas number 7 ends up just being 7 because the index number is 3, and we have 3 of them. Again, it would be the third root of 7 raised to the third power, so they cancel. So again, we'll talk more about that tomorrow. We actually probably won't get into third roots very much, but it might be a good extra credit question. Okay, moving on. Now we're going to do some multiplying where we have coefficients. We'll have some that have thing to realize is, and I don't know if I said this before, I think I said it a couple days ago, but you can multiply whole numbers by whole numbers, and you can multiply radicals by radicals. You cannot multiply whole numbers by radicals. So for instance, number 8, you can multiply the 2 and the 6, that's 12, and you can multiply the 5 and 8, you can multiply this 2 and 6. It's not that hard to remember, but there are times it gets a little bit tricky. We'll talk about that later. That is also should be 48, it should be 40. But once you're done multiplying, a lot of times you'll be able to reduce a radical. So that square root of 40 you can reduce. Ends up being 4 and 10. We talked about that earlier. Square root of 2 and square root of 10. Multiply the 2 and the 12 is 24. So 24 root 10. Say now we have some variables, but again, the 4 and the 2 multiply together, so that's 8. And then 3 and 5 is 15, and then x squared times x is x to the third. Remember, when you multiply with exponents, you add the exponents. Once you get here, we've done this problem already. So again, I know that this problem takes a little bit of time, but the new stuff isn't too bad. So we end up with, we have 8 square root of 15 and the square root of x to the third. The square root of 15, we can't do anything with that. That's as simple as it can get. There are no perfect squares. But remember, this is where we did that rule where a multiple of the index number, so a multiple of 2 as close to 3 as I can get without going over, is 2. We have to have all of them accounted for, so we have the 2 and 1. That makes up the 3. So that cancels. We have x square root of x. So now we have 8, 15, x square root of x. Everything that's not inside the radical goes together. Everything that's inside the radical goes together inside of a radical. Now again, most of that difficulty and a lot of that, I would say, confusing part is the stuff that we've already done. We did that back when we did section 1 and section 2. I'm not saying that because it's easy. I'm just saying that we've done that. Hopefully you guys remember. If not, we need to make sure we're asking questions and studying. I'm going to skip over number 10 real quick because, again, it's got a negative and I don't really necessarily want to deal with that right now. These are third. So we have 50 times 15. We have x's, and then we have, z and z to the first. So that's z to the sixth. Sorry. once you get here, that's the new part. I think it gets difficult. Now we split it up. We have the third root of 50, the third root of x squared, and the third root of z to the sixth. So up again, hopefully you know how to do this part by now. If not, let me know. But that one, 125 works. One is from our list. So we have the root of 125, the third root of 6, five. The other part, the third root of x squared, that's as simple as that can get. Again, the index number is bigger than your exponent. So that's already simplified. And again, if you tried to simplify that, what's a multiple of 3? As close to 2 as I can get without going over. The smallest multiple of 3 is 3, and that's already too big. So that's why that's reduced. And then the last one, 6 divided by 3 works out really nicely. That is just z squared. Again, if you can divide that, that works out nicely and cancels out the radical. So last but not least, again, anything that is outside the radical goes together. Everything that's inside of a radical all goes in the same radical. Just don't forget that it's a third root. And again, this is everything we did over here is all the stuff we did from 8.2. This is the only new stuff from this lesson. Everything else is stuff that, again, if you're not good at it by now, or if you're not comfortable with it, or if you're completely lost, ask questions, watch the video, do something because you need to catch up. Because again, every lesson we've had so far, every lesson that's going to be on the quiz, we have reducing radicals in there. Every single one of them. For time purposes, I'm going to go ahead and skip the you-do part, and we'll go on to the multiplying the binomials. Anything crazy? We're just you have to remember whole by whole numbers, radicals multiplied by radicals. So for instance, when I have the square root of 3 times 2, a lot of people are going to put the square root of 6. You can't multiply those because one's a radical and one's not. That's just 2 root 3. That's all you can do with that. 5, now those are both inside radicals, so those you can multiply. Again, before we do anything else, check to make sure you can reduce anything. The 30 and the 15 you can't reduce, so that's your answer. But again, that's the biggest thing. Make sure you do that distribution and remember that rule. So 2 times 4 is 8. 2 times 3 root 2, the 2 and the 3 is 6, and then the root 2 just stays. Again, check to see, but that one you cannot. Then going into where you have distribution or double distribution is what I always call it. Some people call it foiling, whatever works. But distribute the 2, then come back and distribute that 3. This is another one of those things where we will do it a lot today, and we will do it a lot when we do the next lesson on Thursday. So 2 times 3 is 6. 2 times the square root of 3 is 2 root 3. Square root of 3 times 3, again, you can't combine those, so that's 3 root 3. And then again, square root of 3 times square root of 3, I always do it this way, where I say it's the square root of 9, and then I go and reduce things later. There's other ways to do it, but that's how I like to do it. So 2 root 3 plus 3 root 3, they have, and again, now is where we're doing adding and subtracting like we just did in the last lesson. Since the radicals are the same, we can combine those. So that is 5 root 3. The square root of 9 reduces down to just 3. The square root of 9 is 3. Now, some of you guys knew that because the square root of 3 and the square root of 3 are both the same number. But again, I like to write it out just so people don't forget. And then lastly, 6 plus 3 is 9. So this ends up being 9, 5 root 3. That does not happen all the time when we get that square root of 9 to cancel or nicely, but it does happen sometimes. So don't think that happens all the time, but it does occasionally work out that way. 4 times 5 is 20. 4 times 16. 2 root 2 times 5 is 10. 2 and 2 root 2 is 8. Square root of 2. I know I can combine. That is 26 root 2. Remember, the square root of 4 is the same thing as 2. 8 times 2 is 16. This again, that's fine. You don't have to. 20 plus 16 there, plus 26 root 2. A lot of them do work out that way, where you can end up canceling. You have a nice perfect, but it doesn't always work that way. Full of that. And the last one I'll do, number 18. Same thing, where we are multiplying. 3 times 3, 3 times 5, so that's 9, minus, because it's negative root 5, 3 root 5. 5 times 3 is positive 3 root 5, and square root of 5 times negative 5 is negative square root of 25. Now, some of you guys maybe remember this, and we'll talk more about this next lesson after our quiz. But when we did, those are conjugates. They're the exact same thing, plus and one's minus. But what that does, remember, these two things will cancel. We have a negative 3 root 5 and a positive 3 root 5. So when you put those together, it's 0 root 5. That cancels. The square root of 25 ends up being 5. So you end up with 9 minus 5. 9 minus 5 is just the answer to this one. Now, make sure you do not change this sign. When we did imaginary numbers, we always changed that sign because I squared is negative 1. This is not negative 1. This is not I squared. It is the square root of 25, which is just 5. So don't change that sign, whatever it is. All right. For time purposes, go ahead and do the win extra ticket. Again, if you're struggling with this stuff, first off, if you're struggling with this stuff, win is a good place for you to be. I know there's some people that they will do whatever they can to not be signed out for win. I have people that show up for my win and don't do anything. But if you're struggling with this, or if you're struggling to pass this class, it's a great resource. To take that seriously, if you need help, that win time, or again, there's videos out there. There's a lot of stuff, but in my opinion, the biggest thing is those reducing square roots, or reducing radicals, rather. This binomial stuff at the end can get a little bit challenging, but I think the hardest part is reducing those radicals.